5.1, but there's some aspects from 5.2 and 5.3 I want to talk about as well. So we're going to talk about addition rule and complements, and we're going to keep it pretty simple. We're not going to do, if you took 105 where you had the addition rule and you had to subtract off the intersection, we're not going to do that. We're just going to keep to disjoint events, and that's all we're going to worry about with this one. We're going to keep it as simple as possible. So, the first thing we're going to do is just define this thing. So two events are said to be disjoint if they have no outcomes in common. That's also referred to as being mutually exclusive. You won't have to know that definition. All of the problems that I'll give you, either in the homework, quiz, test, whatever, they will be mutually exclusive. So you don't have to worry about figuring out if they are or aren't, because we're just going to have one formula anyway. So two things that can't happen at the same time. So if you're drawing a card and you're looking at the event getting a 2 and getting a queen, those things are going to be mutually exclusive or disjoint because they can't happen at the same time. There's no outcome, there's no card that's both a 2 and a queen. So those things are going to be disjoint. An example of something that wouldn't be disjoint is drawing a 2 and then drawing a diamond, because they do have one outcome in common, and that's the 2 of diamonds. So those two things can happen at the same time, so those wouldn't be disjoint. But we're not going to do those right now. We're going to just stick to the ones that are disjoint. They don't have any outcomes in common. Then we've got this nice little Venn diagram right here. If you did 105, you're familiar with those. It's just one example. You don't have to draw out Venn diagrams or anything like that, because we're not going to get that deep into it. But with this one, we're looking at a chip from a bag, where they're labeled with the 10 digits here. And we're looking at two events. E is going to be choosing a number less than or equal to 2, so 0, 1, or 2. F is going to be choosing a number greater than or equal to 8, so either 8 or 9. Those are our two events. Notice they don't have any outcomes in common. There's no number that's both less than or equal to 2 and greater than or equal to 9. So there's no overlap right here. There's a little space in between. And then here on the outside, you've got all of our leftover numbers that aren't in either E or F. That's what its Venn diagram does. Like I said, you won't have to draw those things out. Oh, you already have the answers on there. That's not good. Okay, well, for this one, we're going to figure out their probabilities. So we're looking at probability of E. So if we're drawing these chips out at random, there's 10 chips altogether. What's the probability that we get a number that's less than or equal to 2 as a fraction? Yeah, so we've got 3 numbers out of 10. 0.3. And then if we look at the probability of F, what's the probability that we get a digit that's greater than or equal to 8? 2 out of 10. Which is 0.2. And so the last thing, right, that they want to do is the probability that we get something in E or F. So what would that probability be? Yeah, so we've got 5 numbers altogether out of the 10 that are in either E or F. That's 5 out of 10. That's 0.5. Okay, and then what you'll notice is here, if you count up, we've got 5 numbers altogether out of 10. So this one's easy to see because it's all out of 10. But if your numbers were a little bit bigger, what we could potentially do is you could notice that if you take this probability here and this probability here, add them together, and you should get 0.5. And so that's going to be our addition rule for these things. It only works if you have mutually exclusive events. You don't have anything in common. If you took 105, you did have something in common, you'd have to subtract those off, but like I said, we're not doing that. So we're just going to stick to being disjoint. We're just going to add them together. So here's our addition rule. As long as they're disjoint, if you have probability of E or F happening, that or is just going to turn into a plus sign. So whenever you see or, as long as they're mutually exclusive, it's going to turn into a plus. So that's if you have 2, but you could potentially have more than that. You can have, you know, if we go back to the card example, what's the probability of getting a 2, 3, 4, or 5? You can do the addition rule with that because they're all pairwise disjoints. So if you've got a bunch of different events here, as long as none of these events have anything in common with any of the other ones, all of those ors can just turn into additions. So you can do that for technically an infinite amount of them, but we're not going to have that many. Probably at most 4 or 5 or so to add those probabilities together. So that's the addition rule. Anytime you see or, it's going to turn into a plus sign. Okay, so for this one, they've got an example where they're looking at the number of rooms in a housing unit. So we're looking at all the housing units in the United States. Right. They don't say how they got it. If it's using the population, I would assume it's based on a sample, and it's an approximation. But the number of rooms, we've got 1, 2, 3, 4, 5, 6, all the way up to 9 or more, and then their corresponding probabilities. The first part is to verify that it's a probability model. So when you have something like this on the homework, if they ask you to verify that it's a probability model, it's going to be a drop-down menu for most of the parts. But it'll be yes, because all of the numbers here, all of your probabilities fall in between 0 and 1. That's the first thing you need to check. And then the second thing you need to check is that if you add all of these probabilities together, what should you get? 1. So double check those 2 things, and I think it's going to be a drop-down menu. All of the numbers are between, all of the probabilities are between 0 and 1. And then you'll say the sum of the probabilities is, and I think you have to type in the 1 for that one on the homework. That's all you have to do for the probability model, which I'm not going to do because I don't have my physical calculator. But those are the 2 things you need to check to make sure it's a probability